Regarding the answers for assignment number 16 involving derivative connections, we're given the graph of the derivative of f up here, and we're asked 5 questions below. The first question asks on what interval or intervals is the function increasing. Okay. So we know a function is increasing when the function's derivative is positive. And a positive derivative means that we are above the x-axis. So we're looking at these two regions right here. So our answer would be from -1 to 2, and then also from, call it 4.5 to 8. And it does say that we need to give a reason for our answer. So our reason is because f prime is positive. And you can literally write out the words is positive or make the greater than 0. Either representation is fine. Next up, we're asked on what interval or intervals is f concave down. Again, we need to get our answer from the graph of the derivative. A function is concave down when the derivative of the function is decreasing. So we need to look and see when is our graph of our derivative heading downward. When is it decreasing? Well, from 1 all the way down to about 3.5, when x is 1, all the way down to when x is 3.5, we have a decreasing function. And also from this maximum, which looks to be at about 6.25, say, 6.25 to 8. So in those two intervals, our graph of our derivative is decreasing, and therefore our function is concave down. So again, we have 1 until, call it 3.5, and also 6.25 to 8. We want open intervals there. And again, the reason why, because f prime is decreasing. A decreasing derivative matches with a concave down function. Question number 3 asks, for which value or values of x does f have a relative max? A relative max occurs when the derivative changes from positive to negative. So back to our picture we go. We have one instance right here where the derivative changes from positive to negative. We have another instance of negative to positive. That's a relative min, so we don't need that one here. And then we're done at 8. We're only going up to 8. So while it does look like the derivative will change sign again at 8, we don't care because we're stopping at 8 there. So we only have one occurrence where the derivative changes from positive to negative, and that is at x equals 2. All right, so x equals 2 because f prime changes from positive to negative. With question number 4, for what values of x does f have a point of inflection? Inflection points occur when the second derivative is equal to 0, or and changes sign. We don't have the second derivative. In fact, we have just the first derivative, and a point of inflection will occur for a function when the first derivative changes from increasing to decreasing, or vice versa. In other words, when the first derivative has a relative max or a relative min. So if we head back to our picture, we see a relative max here, a relative min here, and a relative max there. Those three values, where the derivative changes from increasing to decreasing, or decreasing to increasing, or once again from increasing to decreasing, and those three values of x, our function, which is not pictured, will have an inflection point. So we can say at x equals 1, 3.5, and 6.25, because f prime changes from increasing to decreasing, or vice versa. Decreasing to increasing. I need to learn to write faster. All right. Last but not least, problem number 5. We're told that let's have f of 6 be equal to -1. Write an equation for the line tangent to f at the point when x is equal to 6. All right. So the hint says use point-slope form, and that's exactly what we want to do. Whenever we want to write an equation for a line, point-slope form is the way to go. That's y minus y1 equals m times x minus x1. Now, we have to plug in for x1, y1, and m. We're given x1, it's 6. We're given y1, it's -1. So we have y plus 1, or minus negative 1, equals, we don't know what our slope is yet, times the quantity x minus x1, which is 6. We have to find the slope. We have to find the slope of the tangent to a curve at a point. We know that from the derivative song, we are looking for the derivative, specifically the derivative's value at x equals 6. So we go back to our picture of the derivative. We go to where x is equal to 6, and we check out this value of the function when x is 6. And the derivative, we can see, is equal to 3. That is our slope. So we have y plus 1 equals 3 times x minus 6.